Hi everyone, this is R. Parthasarathi. I am working as an assistant professor in the Department of Civil Engineering in Hindustan College of Engineering and Technology. So we move to the presentation. My subject is strength of materials. I need to take a session. The topic is introduction to stress and strain. So a strength of materials, you know that a strength of materials, also called as a mechanics of materials, is subjected to which deals with the behavior of a solid object. That object is tends to the stresses and strain. So this study of the materials often refers to the various methods we have to calculating the stresses and the strain in the structural members for the beam and a column and a shaft. In a rigid body is defined as the body on which the distance between the two number of the points, whether whenever it changes, whatever be forces are applied on it, that is the rigid body. Practically, there is no a rigid body. A deformable body, you know that a member is tends to the some deformations. We call it a deformed body. The picture is clearly says that a deformed body is that the distance between the 2 points it changes under the action of some forces when applied on it. The study of this property of this body is called as elasticity. Elasticity says that the property of the body by virtue of which it turns to regain its original shape and size when deforming or force is removed. All solids show the property of elasticity. A simple way stresses, a stress is applied force or a system of the forces is tends to deform a body. It is called as a stress. We call it a sigma. The types of stresses. The stresses is developed in the body depends upon how the external forces are applied over on it. On the basis of there is a possible for dividing the normal stresses and tangential stresses. Normally, we call a stress is equal to load by area. We call stress it's a normal sigma is a normal stress and P capital P that is axially we applied forces on the member. A it is a cross sectional area. A normal stresses of two types: tensile stress and compressive stress. Whether the direction of the forces we call it is expanding, it is called as tensile. It is decreasing the span, it is compressive forces or compressive stresses. A tensile stress is stresses states leading to expansion, increasing the geometrical property of the dimensions. That is the length of the material tends to increasing. That is the best example for the tensile stress. So we take this experiment investigation in the universal testing machine. A ductile behavior, a solid material's ability to deform under tensile force. A best example for the copper wire. Whether a compressive stresses, a forces or attempt that sequences are compressive of the material, it tends to do some cracking or breaking or deformed shape. That's all. And tangential stress, a forces is acting in a general horizontal direction, especially for the forces produced in mountain, folding it over on it. Okay, it's called as a tangentially we apply the forces. Whether delta x is a deformed distance, a it is the top surface of the material, f is the force applied on it. Brittle behavior, that means a member or a material will break subjected to the stresses. That's a glass, it is a good example for brittle material. Strain, a strain is the changing in dimensions or original dimensions. We call it is a strain. Okay, whether it is a lengthwise, whether it is a breadthwise, whether it is a depthwise, or it's volumetric wise, the strain will be applicable for all the members. So types of strain we call longitudinal strain, volumetric strain, shearing strain. Longitudinal strain, it is a lengthwise a member span will be changing. Okay, like it's called longitudinal strain. Changing length by original length we call it is a longitudinal strain. There is no unit because of mm by mm it is cancelled. So a strain it is always no unit. Volumetric wise, the member volume slightly changes whether you apply some forces on it. That volume it will be changed whether it is x direction, y direction, z direction. Total volume it will be deformed, like it's called as volumetric strain. We also delta V by V. This is a formula for finding the volumetric strain. Here also there is no unit. Shearing strain, it is when the deformed forces is produced with some changes on the shape of the member. Yeah, it is the some measure by the angle theta. We call it the radian, through which the line originally perpendicular to the fixed face is turned due to the application of the tangential force. So we call a formula for finding the shearing stress that is equal to a strain that is equal to theta. Theta is always is tan theta. We call it is a delta x by L. So this is the example figure for finding the shear strain. Elasticity is tends to some solid materials to return the original shape after being the applied forces on the them. So the forces is removed, the object will return to the original position. So these words, the deformation disappears completely after removal of the external force. The elastic limit we call, yeah, elastic limit is the stresses states from the elastic body will recover its original state after the removal of the deformed body. This limit we call it is a applicable limit or proportionality limit to the member. So limits of proportionality, like it's a force by extension, it is called as a proportionality. So the extension is directly proportional to the applied forces. State by every stresses is proportional to the strain, like we call a Hooke's law, the best example for finding the limits of proportionality. Then limit of elasticity. So a proportional limit and elastic limit and failure state. So this is the limits. Okay, whether a short term, a value of the forces is up and within which the deformation entirely disappeared on the removal of the forces is called as a limit of elasticity. So yield limit. So by lower yield point and upper yield point, this is the limit for the yield point, whether the after the proportionality of limit. So the portion fill upper and lower yield point, we call it the yield stages. Ultimate stress, okay, in the elastic region and plastic region, the ultimate stresses are applied in the maximum of the stresses are reached at the E point. The big picture is clearly says this E point, it is called as ultimate stress after the elastic region, plastic region. Before the fracture point, it is ultimate stress point. So strain hardening, a material will some deformations will be predominance in increasing the some stresses from the D to the E point is known as the hardening point. So D is the yield point and AE, it is the upper stress point. Okay, this is a before the fracture point. So this location it's called as strain hardening point. Modulus of elasticity is the Young's modulus E we call modulus of elasticity in this measuring of the stiffness of material, elastic material. Thank you.